Um, Combinations and the binomial theorem.
Okay. So let's talk about combinations first.
All right.
If I give you this problem, hold on, everything's getting sketchy on me. Usually takes a second trial here. If I say 4, choose, let's make it 5, choose 2. How do I figure that out?
We just put it in our calculators.
Okay. Do you ever have to do it manually?
He taught us like how to do it manually, but he didn't like show us his formula with it.
And then there's another letter that goes here, and I always remember there's 2 N's and 2 R's. So that's got to be an R. Everything's factorial. So this would be 5 factorial over 3 factorial times 2 factorial.
Okay.
And it's worth knowing how to do these manually. In other words, the 3 factorial takes care of everything but the 5, 4, the 5, and the 4. That's divided by 2, so that's equal to 10.
Okay.
In other words, the top was this, all multiplied together. The bottom was this, and that part crosses out with that part always. So the only thing you're left with is 2 times 1, so that's how you get 10.
Okay.
And I would think that they would want you to be able to do that some way other than your calculator. I've never heard of anybody being able to rely totally on your calculator. And you've had permutations also?
Yeah, so that's the lesson we did today.
Okay, let me give you the formula for that. It's very similar, only this one only has the n minus r in the bottom.
Okay.
So there's always more permutations than combinations. Because combinations is divided by that extra r. In other words, if I did 5 permutation 2, my answer would be 20.
Okay.
Now, the binomial theorem. Shall we write it? Probably need to put it up there once. A plus B, or do they use A, X, and Y? What letters do they use? Do they start it off like that?
They use N and R.
Okay. So, it usually ends up being 0. Am I close? I'm not looking at out a book. No, hold on. Let's see. This next one is n over n minus 1, isn't it?
I don't see that equation.
Hold on. Let me get my book to make sure I'm not screwing it up here.
Okay.
I am screwing it up. I almost never apply it, so I don't. I thought I remember it. Hold on. Everything begins with this, so 681 in my book. Alright, here we go. Yeah, I was wrong already right here. That's a 0. And then it's a to the n. There's no b term in the first term. Actually is, it's b to the 0. They just don't write it. And this one is n1, a to the n minus 1, b, plus, 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 n over r to the a to the n minus r, b to the r, and then that's the second to last term, and the final term is n over n, b to the n. So that's, whoops, hold on a second. You still there? I'm knocking my microphone over. So now give us some problems.
Okay. Let's see. All right. There's one. It says 10 to the c and then 2. I don't know how to say that for combinations.
Oh, 10 choose 2.
Yeah. Okay.
This is said choose, and the P is said pick. In other words, it's 10 choose 2 or 10 pick 2.
Okay.
Because that's kind of what you're doing, is you're choosing 2 out of a possible 10.
Okay.
Okay. And they just want what? What that number is?
Find the number of combinations.
Okay. So this is not going to be terribly useful if it's just you putting it into your calculator.
Yeah.
Here's what I would do. It's 10 factorial. I think it's important that you learn this.
Yeah.
So what's the denominator? What's n minus r?
Is it 8 factorial?
And then what's r?
2 factorial?
Yeah. So that's how you set it up. And these are actually fairly easy to solve because, like I said, the 8 takes care of everything but 10 times 9.
Right. Okay.
2, so that's 45.
Sweet. Yeah, that is easy.
Yeah, it's not bad. And gotta believe you're going to come across problems where they need you to be able to do it manually. Maybe not, but what else you got?
Okay, so these next problems are card hands.
Okay.
Find the number of possible 5 card hands that are specified. Okay, so this problem is 5 face cards, and they're either kings, queens, or jacks. Yeah, so face cards.
And they want what? The combination of what? Or what? How many hands that contain a king, queen, or a jack out of 5 card hands?
They want the number of possible combinations.
Between king, queen, and jack?
Yeah.
Okay. Well, let's look at this a couple of ways. I'm assuming this is a counting problem. Okay? And you need to be able to do counting problems manually. At a point in time, you won't do them manually. You'll do them using combinations and permutations. But I can start with the king, and then queen, and then jack. I can start with the king, and then jack, and then queen. This what you're talking about?
Oh, yeah, yeah.
I can start with the queen, and then it's king, jack. I can start with the queen, and it's jack, king. Or I can start with the jack and go king, queen. And I can start with the jack and go queen, king.
Oh, okay, that's easy.
Now, yeah, and notice that there are 6 different permutations of king, queen, jack.
Right.
And permutation is going to be 3 pick 1, which is 3 factorial divided by, no it isn't, 2 factorial. It's not 3 pick 1. Why do I always have problems with that? Figuring out how to put that into a combination. But you'll notice if order matters, there are 6 different permutations. If order doesn't matter, there's only one combination. King, queen, and jack, and you don't care what order they're in.
Right.
You know how poker is played?
Yeah.
If you get a flush, you have 5 hearts. You
Mhm.
don't care what order the hearts are in. You don't care if you got the ace hearts first, last, whatever. The 5 cards, it is a combination problem because they don't have to be in a particular order.
Right.
Now, I don't know why I can't come up with, this is a permutation problem. What would it be? It would be 3. Pick, it's got to be 1. No, it's not 3 because that would, 3 pick 2 would come out to be 6. Because that would be 3 factorial over 1 factorial. And that's 6.
Mm-hmm.
And in a way, I can kind of see how this might be a 3 pick 2. The only thing I can see is that we're always picking 2 as our... No, I don't know. 3 pick 2 doesn't seem right to me. But anyway, a counting problem you can do by hand.
Right.
What else you got? I'm going to leave that binomial up there because you're going to give me some of those. In other words, if I gave you a binomial, just tell me if you have any of these, because if you do, probably ought to cover it. These are extremely long problems. You got any problems that say, what's the 5th term of that expansion?
I have some binomial theorem problems.
Okay, let's do at least one since we're limited to a half hour here.
Okay. All right, so it's x plus 4, and it's all in parentheses, raised to the 5.
Okay. They want to know what it is?
It says use the binomial theorem to write the binomial.
Cool. So what's the first term? What's the first thing? In other words, that's why I wrote it across the top, because I knew we were going to have to plug into it at some point. So what's n?
N is 5.
Okay. What's next? You tell me.
And then it's x raised to 5 plus 5 over 1.
5 choose 1.
5 choose 1, okay. And then x raised to the 5 minus 1, which would be 4. And then b is 4.
We'll just put it in parentheses for now.
All right. And then 5
Choose 2.
2.
There's a pattern here.
Yeah. And then 5 minus 2. Right.
Yeah, notice it's going to count down from 5, 4, 3. And the number is going to count up. The last one was 4 to the 1 power. This is going to be 4 squared.
Okay.
Okay. Keep going.
And then 5 pick 5.
5 choose.
Oh, 5 choose 5.
3. No. In other words, we got to get all 5 terms.
Oh, okay.
Okay, hold on a second. There are actually 6 terms. So let me do it this way. The next one is 5 choose 3. That's the rest of it.
Let's see where we're at.
If you look at my screen, the row above it, you can see on the right side.
And then is it 4 to the 5?
Hold on. What's the x power?
To the 5.
No, we're going one at a time. In other words, look at what's happening to our x variable. It starts at 5th, then 4th, then 3rd. This got to be 2nd.
Okay, yeah.
Look what happens to the 4. It's to the 1 power, to the 2 power. This got to be 4 to the 3 power. Keep going until you end up with no x's anymore.
Okay.
It's the next coefficient. 5 choose what?
5 choose 4.
Keep going.
And then x to the 1.
Correct.
And then 4 raised to the 4.
Okay, and then finally the last term.
5 choose 5. And then x
To the 0th, if you like, but x to the 0th is 1. In other words, notice the first term had no b, had no 4 in it, and the last term has no x in it. It's just 4 to the 5th.
Okay.
Okay. Now, that needs to be simplified. In other words, we need to know what 5 choose 0 is. What is 5 choose 0?
Is that 1?
What's 5 choose 5? That's also 1.
Okay.
Because it's 5 factorial over 5 factorial times 0 factorial. The key thing with factorials is the one that doesn't make a lot of sense is 0 factorial. 0 factorial is 1, believe it or not. It is the same as 1 factorial.
Okay.
Now, first time I ever heard that, I thought, oh boy, that's just mathematicians making stuff up so that everything works out. But yeah. I don't think that is the answer. I think the answer is no, 0 factorial really is 1 in the realm of higher mathematics. So you would turn each of these coefficients into a number. Now, here's a question you might get asked. What's the coefficient of the third term? Well, there's the third term. What's the coefficient of that third term?
Total?
Yeah, that's the thing, is you have to take into consideration the 4 squared also. So 5 choose 2 is 5 factorial over 3 factorial times 2 factorial. And you'd have, what is that? That's 5 times 4, that's 10. Times 4 squared, 16. So the coefficient would be 160.
Okay.
So in other words, that third term is going to be 160 x cubed.
Oh, wow.
That's it. That is the third term. So you can see the value of this thing, because who the heck wants to multiply that out 5 times?
Yeah.
And they'll also have problems like to the 15th power. In other words, there's some exponents you're not going to be able to do it even if you wanted to manually. And so this binomial theorem is pretty clever. I don't know who came up with it, and why it's related to the combinatorics is another mystery. It has to do with Pascal's triangle. The binomial theorem expansion is very similar to Pascal's triangle. Have you studied that?
We have some problems on here.
Oh, okay. All right, so we've done one binomial expansion. They can get harder if there's coefficients. In other words, if that was a 3x plus 4 or a 3x plus 2y, then those coefficients really get big fast.
Oh, yeah.
Because you're like cubing 3x, which gives you 27x cubed.
Okay.
All right, what other problems you want to go over? You got about 10 minutes.
Okay. Is that enough time for a Pascal's triangle one?
Well, I think. Depends on Yeah, here, hold on a second. I've got I'm sure, no, I don't have one. How can I not? Here, yes, I do. Okay. So, Pascal's triangle goes like this. Down the outside is all ones, and on the inside is the sum of the two numbers above you. In other words, that's got to be a 2. That's got to be a 3. That's got to be a 3. That is a 4. That is a 6. And that is a 4. You see how I'm creating it?
Yep.
Well, guess what? These coefficients are the same coefficients you get when you do the binomial theorem. For example, if I do x plus y squared, we know what that is. X squared plus xy plus y squared. Well, that's row 3. Coefficient is a 1. Excuse me, it's 2xy. In other words, look at the coefficients of those 3 terms. 1, 2, 1 matches the third row of Pascal's triangle.
Okay.
So whatever this exponent is, you need to go to that exponent plus 1 in Pascal's triangle. In other words, go ahead and give me your problem, and then we'll...
Okay. X squared plus y raised to the 7th.
Like this?
Yeah.
Using Pascal's triangle?
Yes.
Okay, I've got 5 rows on there. I need 6, 7, 8. It's going to be whatever the 8th row is going to be our answer. 6, 7, 8. Okay, so that's 5, 10, 10, 5. And if you don't know what I'm doing here, stop me. You know what I'm doing, right?
Yes.
I'm adding the 2 numbers above it. And you'll notice a pattern. Look at the second diagonal. It goes 2, 3, 4, 5, 6, 7. Okay, so this is the row. Unless I screwed up here and didn't do my math right. No, I'm sure I got it right. Is that 1, 2, 3, 4, 5, 6, 7, 8. So it's the 8th row. So what is this expansion going to be equal to? I'm talking about from over there. What's the first coefficient?
1.
1 what?
1 x squared plus y.
Well, look at the first term. Never has the y in there.
Oh, okay, I see.
Okay? So the first term is just x squared. Plus, the second term is what?
7.
Hold on 1 minute. Let's talk about our exponents. You can't worry about just the coefficient. You got to worry about our exponents. The exponent's got to be 7 times 2. So that first exponent's got to be 14. Right?
Oh, yeah.
And it's x squared to the 7th power.
Right.
Okay, the second term. Now this is where it's x squared to the 6th power. And this does have a y in it, and it's y to the 1. In other words, this term right there. And the coefficient, I got it. In other words, that coefficient came from 7 fused one at a time, or Pascal's triangle. What's the next term?
21x.
This should be 12. In other words, that was x to the 6th. It was x squared to the 6th power. Sorry.
Okay.
Don't keep messing up. But okay, so this is 21 what?
X to the 10?
Yes. Now you're getting the pattern down. Y what?
Y squared?
Mm-hmm. Okay, plus
35x to the 8. And then y to the 3.
Plus
35x to the 6. And then y to the 4. 21x to the 4 times y to the 5 plus 7x squared times y to the 6.
there's always going to be one last term. You got to have a y to the 7th at the end.
Okay.
The coefficient on that is 1.
Okay, so would it be x squared plus y to the 7?
Oh, the x is, it's x to the 0, notice.
Oh,
Which
yeah.
is 1. But remember, on that first term, you don't have any y, and on the last term, you don't have any x. When it's an x plus y to the 7th or nth power.
Okay.
Okay? So there's your answer, and I have to say that's probably a little easier than using the binomial theorem. In other words, doing all that choosing.
Yeah.
Although you do have to have Pascal's triangle either in front of you or you have to be able to create it. I suppose
Right.
the key to know is that you go to row n plus 1. You don't go to n, the nth row.
Right.
And you can always figure that out by doing just x plus y squared.
Sweet.
All right, Jake, I'm going to let you go. I do have a 6:30 session.
All right. Thank you.
You're welcome. Bye-bye.
Bye.
Yeah.